Alright guys, it's Saturday morning. I'm going to see how close I can get this engine to finish assembled today. So here I'll show you what I'm starting with. I got the front little cover thing with the crank seal in it for the snout of the crank, and I found a socket that pretty much fits it pretty close. So I'm going to drive that out, and I'm going to drive a new one in. And then we'll put that on and put the rear main seal on also, remembering to at least put the oil pump chain in there before I do that. And then we'll get going putting the cams in and figuring out the timing on this motor. I'm going to be making some stuff for the timing related issues that I see in the industry. But I'm going to kind of get it close anyway, and show you guys like how to prime the oil pump and things like that. So anyway, let's get going. Alright, so I'm going to drive this seal out. Pretty easy to do. And then we got to drive the new one in, but I'm going to go kind of wash this up real quick first. It's pretty clean, but I want to make sure that there's nothing hiding under there and I didn't get anything on it from the table or anything. Alright, so I got this clean. I put down a rag to protect the sealing surface here. I don't want to put any dings or dents in that. And then I'm going to basically oil up this new seal, just really lightly oil the edge of it and the hole. And then I'm going to find something flat, like this little block, so that I can drive it in flat up against the little lip that it goes into, basically. So light oil. And then I think this will work. So just kind of watch it as you do this. Try to keep it as flat as you can. And that's it. She's in and she's flat. Next thing. Okay guys, so installing the oil pump, pretty straightforward, just 3 bolts. Doesn't have to be timed or anything. But this is one of the most important parts of your engine, is the lifeblood of your engine. So make sure, see that, made in Germany, Phoebe, make sure you get a good quality oil pump. The other thing you need to make sure you do is that you prime it. So pretty simple. When you prime an oil pump, basically you're just wanting to wet the surfaces with oil so that it can actually create a vacuum once you start the engine, so it seals properly. So basically you just want to get some oil in there and hopefully it kind of stays in there. So all I'm going to do is, since this motor's vertical, and we can't tilt this engine anymore because if you remember the buckets are in it, we don't have cams in it, so the buckets would fall out. But more importantly, the buckets are pumped up with oil and have oils in the top of the little check valves. So we don't want to flip this engine over anymore, basically. So now that we have the buckets in there, it pretty much needs to stay vertical. And that's kind of hard to prime an oil pump because a lot of times guys will want to flip the motor over and kind of fill the oil pickup with and crank the motor over by hand to make sure it's got some oil in there, which isn't a bad idea, but since we're dealing with the hydraulic lifters, it might not be a great idea. So what I'm going to do is the oil pressure outlet here on the pump, I'm just going to fill that up with oil, and I'm going to rotate the pump by hand just a little bit to make sure oil's kind of coming out of the pickup area there, and the gears are completely wetted. So pretty simple. Alright, so I've got the gear all wetted out in there. It's dripping a little bit of oil, but that's okay. I'm just going to fill this up the rest of the way. And, kind of make sure it stays wet. Wipe off this surface here. And then we just need to bolt it up. So this is a little awkward because we can't flip the motor over. But basically just need to get it on this chain ring here. Three bolts. So it's pretty important to torque these ones correctly because you do have that sealing surface where the oil pump interfaces with the block, with the oil galleys in the block. So you want to make sure you get this one torqued right. So I'm going to go figure out what the torque's supposed to be, and I'll be back. Alright, so 12 foot-pounds on these oil pump bolts. That's the important one. And then 11 foot-pounds on the tensioner. This thing, you put the little hook of the spring underneath the bottom of the block, kind of in between the main cap and the casting of the block, and then you just squish it down and thread it in, and then yeah, it's pretty straightforward. You guys will see. Seems not very tight, but all right. So there's that, and now I'm going to get this prepped and ready to go on. I'm going to oil the seal. And then I'm going to put some RTV around here. I don't have the Volkswagen RTV, so I'm going to use the Ultra Gray from Permatex. I'd rather use the Volkswagen stuff, but I don't have it. But this is the high torque. The gray is the high torque, so it's made for flat surfaces like this. And it basically doesn't all squish out. So that's what I'm going to use. Forgot to oil the seal. So these bolts are also 11 foot-pounds. I'm going to kind of do a semi-star pattern here. Alright, that's done. Alright, let's install our pin timing gear here. I'm going to put one pin in here. I'm going to drive this other one in. That thing is very solid now. I am going to go ahead and drive that in with like a punch. Those are solid. So this is a new bolt for the timing gear, the crank gear. I'm going to go figure out what torque that's supposed to be, and most likely I'm going to use like a block of something to keep the crank from rotating, so that I can torque that accurately and actually get it to proper torque, which I think probably a lot of people have a problem with, especially if it's in the car, because I'm sure it's a lot. So let me figure that out and I'll be back. Okay, so main crank bolt torque is 67 foot-pounds-ish, about 66.3, but we'll do 67 plus a quarter turn. So what I've done is I found a little block of aluminum that I had, and you guys can use whatever you can find that it's about right, you know. But make sure you use like a soft metal like aluminum or a plastic or maybe even wood if it's a good hardwood that's not going to like shatter. You want something solid enough that when you start putting torque on this crank, it's not going to give any, because that quarter turn is pretty important, and you don't want to have it flexing and things like that, or maybe, you know, explode halfway through torquing it, you know, because then you don't know where it ended and you're basically buying a new crank bolt at that point. So I'll show you what I got going on here. So I'm going to put this block in right up against the side of the block and up against the side of the rod. So basically the crank, once I start torquing on it, it won't be able to turn very far, and then it'll stop. And hopefully it'll hold itself there, but we'll see. So I'm going to hold that there and start putting some torque on this to, you know what, before I do this, I need to make sure I mark where TDC is. We'll be able to put the cover on and the pulley on later, but I want a reference point anyway, just to make sure we don't, end up way out. There's no cams in the motor yet, so it doesn't really matter, but, just for reference, I'm going to do that. So, 67 foot-pounds plus a quarter turn. That did not seem like 67 foot-pounds. Maybe it was. I'm going to double check that with a different wrench. Just to double check, I'm going to check that torque with this wrench. Yep, it was 67. So, now we got to go quarter turn. So what I've done is I've gotten a long breaker bar, half-inch drive breaker bar. This is a 19 millimeter 12-point nut, by the way. And we're going to go a quarter turn. Alright, so our quarter turn is about down here. So that's what we're going to go for. It's pretty close, I think a little more. Yeah, I think that's about right. So you can see that quarter turn is a lot of torque. And that's probably what a lot of people have problems with when they're installing these crank pulleys, especially if it's in the car or something like that. The only real way to do that is to hold the crank from moving somehow. So, if you're doing it in the car, maybe pull the oil pan and stick a block up in there just to be safe. But anyway, that's there. So that's it for that. Okay, so the rear seal plate I'm not going to be able to get on while the engine's on the engine stand. It's just too close. Sometimes you can get them. This one doesn't have near enough room. So I'm going to skip that for now until we're about ready to put the thing in the car. So this is going back in the box. So I'm going to move on to the cams. And before I put the cams in, I need to do two things. I need to put new cam seals on them, and I need to put my adjustable cam gear on the exhaust cam there. So I'm going to do that, and and then we'll go about dropping the cams in, making sure everything's timed up properly. Not going to be able to rotate the motor after this. I'm not actually putting the timing belt on yet because I don't really like the hydraulic tensioner. Obviously that's a failure point in a lot of the higher RPM engines. And I don't really like the products that are available as far as the manual tensioner setups. So I've got some ideas of how I want to do it, so I'm going to actually build my own tensioner, and I think it'll be better than anything else that's available. So I'm going to skip that part for now because I got some work to do on that. But I'm going to go ahead and swap out these cam gears and put new seals on the cams. Alright, so basically what I'm going to do is I'm going to grab these in a vise, these cams in a vise, and I'm going to grab it right on a lobe so I can use the lobe as a means to keep it from rotating when I'm torquing it. But I want to protect them, so I'm going to fold up a towel here, semi-clean towel, and I'm just going to lay it into the vise just to help protect that cam gear. Because you don't need it real tight because you're going to be working against that cam lobe. But we don't want to score up the lobe or anything, so we're gonna protect it a little bit. So I'm gonna just grab it on the highest lobe closest to the bolt that I can, and make sure it's deep enough in the vise to where it's gonna actually use the cam lobe. And I'm actually up against the table down here, so I'm going to throw another towel kind of underneath that and make sure it doesn't ding up anything on the cam. So just snug. Show you. So I just have it sitting in there up against the cam lobe. Rotated the right way to where I can loosen this bolt and it's not going to spin it. You don't want to spin it in there at all because it could cut through the towel and damage the lobe. So we'll break this one loose. So this is your little cam trigger, so your sync signal for your engine. And it's got a little tooth there that goes in the longer of the two cutouts. So there's a cutout in this long side where it goes all the way through to the outside. That's the side that tooth goes into. So make sure you make note of that. So I'm going to pull this seal off. And then I'm going to go kind of clean this cam up because they've been sitting out and they're a little dirty. So I'm just going to go hose it off with some brake clean. Make sure there's nothing, no foreign objects on it or any metal because I'm in a damn machine shop. But yeah, so I'm going to go clean this off real quick and I'll be back. Okay, so I got that clean, more or less. I'm going to put the new seal on it. So both these seals are the same for each cam, so it doesn't matter which one goes where. So I'm going to put a little bit of oil on the cam and on the seal, just lightly, and then carefully put the seal on. You're going to make sure you don't get this thing folded over wrong, like I just about did right there. So it helps to kind of put some tension on the seal, like push up against one side at an angle and then kind of work it down so that it doesn't fold that seal over onto itself, because then you'll end up with a pretty serious leak. Okay, so I'm going to clamp this back in the vise. I'm going to clock that lobe the other way since we're going to be torquing it now instead of loosening it so it doesn't spin in the vise again. And this one I believe is, I'll have to go double check, but I believe it's 14 foot-pounds. I could be wrong. I'll go double check and be right back. So I was wrong. It's 18 foot-pounds and 48 foot-pounds on the cam gear. So this is the cam position wheel, and then the other one will be the cam gear. So this one's 18 foot-pounds. So 20, 18. So we'll reinstall this cam wheel. Kind of wiping off the surfaces, make sure they're semi-clean. Again, the tooth goes in the long side. I don't think it can actually go in the other side, so it'd be pretty hard to screw that up. And 18 foot-pounds on this guy. I gave it just a little extra because 18 didn't seem like enough, but it's not going to hurt anything. Okay, so that's the intake cam. It's done, so now we'll do the exhaust cam. So same deal. We'll pull this apart, go clean it, and put it back together. Okay, so semi-clean, a little bit of oil, and then carefully work that seal on again. Then we're going to put our new cam gear on there. I'm a little stickler for things not coming loose, so I'm going to torque this and I'm going to put a little bit of blue Loctite on it. Blue is not permanent, but it'll definitely help stuff not back itself out. That's that. Okay guys, so I'm getting ready to do these cams and drop them into the engine, and we need to basically make sure everything's kind of timed accordingly so that we don't bend any valves by hitting the pistons with them. So what I'm going to do is I've installed the, here, let's point down. I've installed the main gear and the little cover, or the main pulley and the little cover, so that I have the timing reference mark there. And what I'm going to do is, because when you install these cams, they're not in time with the crank. So basically you have to line up some notches on the other side of the cam, and when those notches are aligned, this isn't at its TDC mark. So what I'm going to do is I'm going to rotate this crank 90 degrees out of phase. So I'm going to probably rotate it counterclockwise 90 degrees to make sure all the pistons are down level and away from the valves. And then once I get the cams in there and set up, and this back to its 0 point, I'll rotate that crank back up 90 degrees into time with the cam gear. So I'm going to go grab a wrench and be right back. Okay, so I got my big wrench. I'm going to throw that on the main pulley nut, and I'm just going to let it rotate the engine down 90 degrees-ish. So now I know all of my pistons are down basically level below the deck height. So now I can time my cam gears with each other without risking hitting any of the valves on the pistons. So what I've got is, I went ahead, I'll try to pull this back out, but I put the chain that drives the intake cam on the exhaust cam, and I kind of just dropped it into place. And then I also have my little donut seal and the little metal gasket that goes underneath the cam chain tensioner. And so all of this stuff kind of has to drop in together. It's kind of cumbersome. So I'm just going to kind of set this in place halfway for now. And then we'll grab the intake cam and kind of put all that stuff into place. Basically, there's some notches on the other side of these pulleys here, the little chain rings, and there's a keyway in the end of the cam, and both of those need to be basically pointed relatively straight up. There's some marks on the last cam caps that have some little arrows that they're supposed to align with, but basically they're dead nuts in line with the cams and straight up. And they also have 16 links between them, or actually 16, I guess, of the little pins that link the chain together. So I'm going to put this exhaust cam so that mark is pointed up, which is basically 90 degrees out of phase with where it needs to be when we time the crank to the cams. And that's why I moved the pistons out of the way, because when we bolt this down and make sure they're in time, it's going to push the valves down, and it could theoretically hit the pistons if it's out of time. So that's why I just rotated the motor down 90 degrees, play it safe, basically. So let's grab this intake cam here, and we're going to kind of try to weasel this in here. And we kind of lift everything up and then drop it back in. But we got to get it timed also. What you could also do is kind of count out your links and mark them so that you know basically where this cam gear has to fall. Sure looks right to me. All right, so let me show you here. So you can kind of see, I don't know if you can see that on camera, you can kind of see the mark on this side where that keyway is. You can really see it on this side, but once this tensioner's in the way, you can't really see that one. But if it wasn't on this camera, you could probably see that little notch there. I don't know if you can see it or not. But basically, these pins in these links line up pretty close to where that is. So So you want to basically count these. So number 1 is the one lined up with the keyway, and then number 16 should be lined up with the opposite keyway. So it's pretty straightforward, and basically that's how you time those cam gears with each other. And then we need to basically start bolting this down, and then once we get it all bolted down, we can rotate this cam into time with the crank, and then we can rotate that crank back up into position safely without the possibility of hitting any valves. So I have to clean a whole bunch of cam caps because they're still filthy dirty, but I'm going to do that. I don't have to show you that to you guys, but I'm going to do that, and then we'll come and start bolting this whole thing down. Okay, so I got all my cam caps clean. I also got all the cam bolts sitting in some oil. So I'm going to start putting this thing together. Before we put it together, we need to get some oil on this cam, and on mainly the cam bearings is what we're worried about. We don't need a lot, but enough to get some oil on there, so that it doesn't have a dry startup, basically. So I'm just going to drip a little bit of oil on each cam bearing. Alright, so I'm just going to start placing everything kind of where it needs to go, and we'll just start kind of sucking everything down slowly all together. The reason I had these soaking in oil is, 1, to help kind of clean them up, and then 2, to basically we want to have oil on the threads and underneath the head of the bolt so that we get proper torque. You know what I forgot to do? We need a little bit of sealant underneath this last cam cap on the cam pulley side. We're also going to need to be really careful about getting these cam seals in there square and seated once that top cap is on. So a little bit here, a little bit across here, and a little bit there, just to seal it in up to where the valve cover gasket sits. I'm going to do this real lightly. There we go. Should be all we need. Make this a little easier on myself. Cam caps get torqued to 7 foot-pounds. Make sure you get these on there numbered correctly. There's a dowel pin location that helps you find where they go, and then they're numbered basically 2 through 5, and then the last cap with the arrow on it goes that way. And then this front cap's pretty obvious. Alright, now that I got all this sucked down, we can go through and torque them all to our 7 foot-pounds. I couldn't find a sequence on this for some reason. but you know, typical is kind of start from the middle and work your way out. So that's what I'm going to do. Looking good. Alright, so now that that's all torqued down and ready to rock, I can loosen up this chain tensioner retainer little dealie, which lets the chain tensioner come out. It's like just a 5mm Allen wrench. Yep, everything looks good. So now I'm going to rotate this to where the timing is close to where it needs to be for the timing belt to align with the crank. And I'm going to verify that my intake and exhaust valves are both up a little bit. Exhausts are actually a little bit compressed, but I think that's because my time is a little bit farther forward. So we're going to have to be careful when we rotate this motor back up and make sure we're feeling for any you know, tension that might be at the piston touching the valve. Yeah, I think we got contact there. I have to double check and make sure I've got all this stuff timed right. Alright, so I found the problem. This is why you be careful. So here's the factory timing gear. There's the timing mark and the keyway. Here's the gear from Tektronix. If I line up the timing marks, look where the keyways are. So this is a full bolt circle off, basically, as far as I can tell. So I got to take all this apart and realign this, and hopefully it lines up perfectly with that keyway. All right, so I figured this out. The timing mark wasn't in the clocked wrong. I was just being an idiot because there's actually a second timing mark. I'm not sure why they didn't use that timing mark for their alignment marks. Maybe it doesn't line up perfectly or something. But I hadn't noticed that there's actually a true timing mark over here. It's basically 90 degrees, a little less than 90 degrees out from their actual adjustment marks, I guess. So I got this back together, but now I got to figure out how to torque this cam again without having it rotate. So I'm going to use the same trick. I got a little piece of aluminum in here that I'm going to basically just let it rest up against the head, and when that cam lobe comes over, it should lock it up and I should be able to torque it. There it is. Alright, so now we can rotate this thing into time and everything should be right. And I'm real curious to get this thing, to get it timed with the timing belt so that I can throw some plugs in it and make sure everything's got compression. Because I'm a little worried because when I felt that contact with the valve, you know, I don't know. If it was a real bad angle or something, there's a lot of leverage on that crank, so it could have damaged the valve. Hey look, our timing marks line up now. And the cams are in the up position on the compression stroke, so everything's making more sense. So now I should be able to bring this up into time without any issues. It feels fine to me. There was definitely some tension on it before. So it could either be these intake valves that hit or these exhaust valves. So I guess we'll just have to wait and see till I get it timed and put some plugs in it and make sure we got no leaky valves anywhere. So I suppose I could do a leak down test on it right now. Maybe I'll do that. Alright guys, it is the next day. I did go ahead and leak down test this motor, and I thought it was really bad news. I thought I had bent some valves by rotating the crank and hitting the valves. So I went into full-on diagnosis mode here, and basically was trying to figure out what was going on. And long story short is I figured out that I've got some issues with a couple of lifters. So if I pull the cams out, the valves seat fine, everything's good. With the cams in, I had a few intake and one, or two intake and one exhaust valve that was leaking. And I was like, okay, maybe it just didn't bleed down right, you know, whatever. So I left it overnight. I had two that bled down decent, but one that was still just locked out as high as it would go. So I think I may have screwed up and given you guys some bad advice by telling you it's okay to mix and match parts. And I can physically tell which ones of these bled down because they have some spring in them now. But the ones that didn't still felt really solid. So what I've done is I've taken those lifters out, and I'm comfortable with the rest of these, but those ones I'm going to replace with some other used ones that I'm going to take apart, clean like we did before, but I'm going to keep all the pieces to each lifter as an assembly so I don't mix and match any parts. So I don't know if that's what caused it or not, but basically I think maybe the tolerances are too tight on the bucket, on the little check valve bucket, and maybe it's just not letting the oil bleed out of there basically. So so maybe you should keep all those as assemblies and not you know, not mix and match parts. So anyway, I'm gonna do that, and then I'm gonna get this top end back together, and then I'm gonna probably let it sit overnight, or at least for a couple hours, and come back and leak down test it again and make sure everything's bleeding down the way it's supposed to and there's no issues here. So just doing my due diligence. This is, you know, stuff you need to check when you're building a motor proper. Again, this is not, you know, don't take this as advice. I'm just showing you my process. Anyway, so I figured it out. Motor's okay. I don't have to pull a head back off or anything, and basically just have to figure out some lifters here. So that's what I'm gonna do, and I will be back when I get this thing all buttoned up.